So problem 5.4 is the last one in this unit, okay, and it's about one-sided limits of you'll see weird functions that are not continuous in these points, okay. So let's see, we have the first one is the limit when x goes to 0 from the right of 1 over x to the integer part of x, and then we have the limit when x goes to 0 on the left, 1 over x to the integer part of x. And if you remember, the integer part of x is this function that is the greatest integer that's smaller than x. Okay, so when x is positive, this is actually the kind of the point, the values on the left on the decimal, right? So this is 1, 2, right? So this is when x is smaller than 0, this is 1. When x is between 1 and 2, sorry, this is 0, 1, and then 2, right? This is a step function that way. Then when x is between 0 and minus 1, this is minus 1, and go on like this, okay? Minus 2, and so on. Now, when you approach 0 from the right, then this function, when you get closer to 0 from the right, this is identically 0, right? So this is the same, saying the limit when x is, or you could say that the integral part of x is, well, it's not only asymptotically asymptotically equivalent to 0, it's equal to 0 when x approaches 0 from the right? So then this is equal to 1 over x to the 0, or if you want, the limit when x goes to 0 from the right of x to the 0, right? Because this is x to the minus whatever, x to the minus 0 is x to the 0, but this is 1, okay? It doesn't matter the value of x. Okay, this is going to be 1. And actually the value of this function, it's going to be 1 in all this interval from 0 to 1, right? Now what happens when you approach 0 from the left, right? You have, well, let me write it like this. This is x to the minus integral part of x, right? So this is equal to the limit when x goes to 0 from the left of, and what's this? This is minus 1, right? The integral part of x is minus 1 when x approaches 0 from the left. Okay, so in other words, this is x to the minus 1, x to the 1, x. The limit of x when x goes to 0 is 0. Okay, so you have this continuity here at 0, right? That's when the limit from the left and the limit from the right are not equal. Now we have the limit when x goes to 0 from the right of e to the 1 over x, and the limit when x goes to 0 from the left of e to the 1 over x. Now, in order to understand this, we need to know how 1 over x works. We've seen this in the lectures. This is the function 1 over x, right? When you approach 0 from the right, 1 over x goes to infinity. So the limit of this is going to be, right? This is e to the limit when x goes to 0 from the right of 1 over x. Now this is going to be infinity, so e to the infinity is plus infinity, right? Now this is the same, the limit when x goes to 0 from the left of 1 over x. When x goes to 0 from the left, this is minus infinity, right? So e to the minus infinity is 0. Okay? And then let's do the last one. 3. The limit when x goes to 0 on the right of 1 minus e to the 1 over x divided by 1 plus e to the 1 over x, and then the limit when x goes to 0 on the right, from the left of the same function, right? Now, so in both cases, right, so we know that from before, right, the limit when x goes to plus infinity of e to the 1 over x is infinity. The limit when x goes to minus infinity of e to the 1 over x is 0, right? So when x goes to 0 from the right, this is going to be much greater than 1, and this is going to be much greater than 1, so we can rewrite the limit as this, minus e to the 1 over x divided by e to the 1 over x, which is minus 1. And when x goes to 0 from the left, right, now e to the 1 over x is going to 0, so this is going to go to 0, this is going to go to 0, so this is the limit of 1 over 1, 1. Okay, so again, two different limits, because these functions are not continuous on 0. Okay, well, they are not even defined at 0, but they're not continuous at 0. And that concludes all the problems from Unit 5.